14, Part 2. This is the second part of Chapter 14 that was supposed to be delivered in lecture on Wednesday, June 13th, 2012. And what we're going to talk about today is actually the determinants of foreign exchange rates in the foreign exchange market. And we're going to do that by looking at the demand for foreign currency as well as home currency deposits, and see how the demand for those two types of currency deposits will determine the exchange rate in the market. But first of all, we need to think about the reasons why somebody or an investor would want to hold a foreign currency deposit. First reason would be the rate of return on that deposit, and a second reason would be the expectations about the appreciation or depreciation of relevant currencies. So investors will take these two things into consideration when they're trying to decide whether to invest in the home country, say Thailand, or abroad, say in the EU or in the US or somewhere else. So how do we compare the returns on deposits from two different countries or two different currency areas? Let's suppose we want to compare the returns on a US dollar account. We'll consider the dollar as the home currency, and a euro account where the euro is the foreign currency. What do we need to know in order to make the comparison? Well, first we need to know the rate of return on the deposit for the home currency. And I'll denote that by an R with a subscript $sign. Second thing we need to know is the foreign currency rate of return, which I'll denote with an R and a euro sign in the subscript. Third, we need to know the current spot rate. So what is the current exchange rate of the dollar against the euro? And finally, we need to know the expectations about the exchange rate in 1 year's time, which I will denote with a superscript E. So let's work through an example to see how we can compare the rates of returns on investing $100. So we want to know, is the rate of return better in the dollar account or is it better in the euro account? So we're going to suppose that the rates of returns and the current and expected exchange rates are as follows. First, the rate of return on a US deposit is 0.02 or 2%. The rate of return on the euro deposit is 4%. We're going to make this easy and assume that the current spot rate is $1 per euro, and we expect in 1 year's time that the exchange rate will be $0.97 per euro. It might be good for you to take a moment and think about whether or not this represents an expected appreciation or expected depreciation of the dollar. And in fact, it should be an appreciation of the dollar. At first glance, it seems like the better investment would be in the euro deposit because it yields a 4% rate of return rather than the US dollar account, which only gives you a 2% rate of return. But let's go ahead and take a look at what the effects of the foreign exchange market will have on the rate of return in dollar terms. So how do we find the expected rate of return on the euro account in terms of dollars? Well, first we need to take the $100 that we have today and think about what it can be exchanged for. Well, it can be exchanged for 100 euro. Second, we put this 100 euro into a euro account, and it should yield 104 euros in 1 year's time, since the return on the euro accounts was 4%. Third, this 104 euros is expected to be worth 104 euros times the expected exchange rate, which is $0.97 per euro, which is $100.88 in 1 year's time. Finally, we need to look at the rate of return in terms of dollars. In order to do that, we need to find the percentage change in dollar terms. So we take the $100.88 minus the original $100 investment divided by 100, and this gives us 0.0088 or 0.88%. So now we need to compare the returns on the two different currency deposits. So the return on the dollar deposit was 2%, and that was given in the original assumptions. We just figured out that the return on the euro deposit in terms of dollars is 0.88%. This means that all investors will invest in dollar deposits and no investors will be interested in investing in euro deposits. So even though originally it looked like the euro deposit with a rate of return of 4% was the better deal, because of the change in the expected change in the exchange rate, the dollar deposit is actually better. I'm going to introduce a shortcut to finding the rate of return on the foreign currency accounts in terms of the home currency. In this case, this is the rate of return on the euro accounts in terms of dollars. And you're welcome to use this approximation unless I ask you on the exam to find the exact rate of return. So first of all, we need to define the rate of depreciation. This is equal to the expected percentage change in the exchange rate over the year. So this is the expected exchange rate minus the current spot rate, and that quantity divided by the current spot rate. If the rate of depreciation is positive, this means that the home currency is expected to depreciate over the year. If the rate of depreciation is negative, this means that the home currency is actually expected to appreciate. In our example, the rate of depreciation is 0.97 minus 1, and this quantity divided by 1, and this equals negative 0.03. Since this is negative, this means that the dollar is expected to appreciate against the euro, which is what we said earlier. So in our example, an approximation of the expected rate of return of foreign currency deposits in terms of home currency is the return on the foreign asset plus the rate of depreciation. Or you can write this symbolically as I have below. So in our example, the approximate expected rate of return is 0.04, which is the rate of return on the euro deposit, plus 0.97 minus 1, quantity divided by 1, which is our rate of depreciation, and this is equal to 0.04 minus 0.03, which is equal to 0.01 or 1%. Note that 1% is approximately 0.88%, where 0.88% was the exact calculation that we did earlier. So again, you're welcome to use this shortcut to find the rate of return of foreign currency assets in dollar terms or in home currency terms, unless I ask you to do an exact calculation. We can also calculate the difference between the home and foreign currency asset returns. The difference in returns between our dollar and euro assets can be calculated as follows. We have the rate of return for the dollar minus the rate of return, expected rate of return for the euro account, which is the rate of return on the euro account plus the rate of depreciation. Or we can write this as R subscript dollar minus R subscript euro minus the rate of depreciation. If this calculation is positive, this means that the dollar deposit is a better investment. If the calculation is negative, this means that the euro deposit is a better investment. So now I want you to get some practice in trying to figure out what is the better investment. So what is the rate of return difference between the dollar and the euro deposits for each of the 4 cases below? And you should be able to answer the question, should you buy dollar or euro deposits? What I'd like you to do is to pause this recording and go ahead and try to find out the rate of return difference between the dollar and euro deposits and determine whether you should buy dollars or euros. So the answer to this simple exercise is for case 1, we found that the rate of return difference between dollar and euro deposits was 0.04. And since this is positive, this means that we should be buying dollar accounts. In case 2, the difference in the rate of returns between the two different deposits is actually 0, which means that both dollar and euro accounts are just as good, so either one. In the third case, we found that we have a negative difference, it's minus 0.04, and since it's negative, this means that we should be buying euros. And in the final case, we found that the rate of return difference is 0.02, which means that we should be buying dollars. Okay, now that we understand how to calculate the rates of returns of foreign currency deposits in terms of the home currency, we can now build our model of the foreign exchange market. We're going to use the demand, or the rate of return, for the home currency deposits and the demand, or rate of return for foreign currency deposits, to construct a model of the foreign exchange market. The market is in equilibrium when the deposits on all currencies offer the same rate of return. The equilibrium condition is actually called the interest parity condition. The interest parity condition says that the rate of return of the home currency deposits equals the rate of return, or the expected rate of return, on the foreign currency deposits. And symbolically, it's written as I have below. So the question is, why is the interest parity condition an equilibrium condition? Remember, an equilibrium condition is a condition where we don't want to make a different decision. We kind of come to rest at a particular decision. So I can prove this by contradiction and say, suppose that the rate of return on the dollar deposits is greater than the expected rate of return on the euro deposits. If this is the case, then there's no investor who would want to hold euro deposits, driving down the demand and price for euros. All investors would want to hold dollar deposits, which drives up the demand and the price of dollars. The dollar would appreciate and the euro would depreciate. This would increase the rate of depreciation until equality is again achieved. At this point, there's no more shifting from euro to dollar deposits. So next, we'd like to graph this equilibrium condition. So the axes in this case are, for the y-axis, this was going to represent the spot rate in the foreign exchange market, and the x-axis is going to represent the returns on deposits in terms of the home currency. The relationship between the returns on foreign currency deposits and the spot rate is negative. The depreciation of the domestic currency today is going to lower the expected returns on deposits in foreign currencies. So let me go ahead and explain what this means. Suppose you're trying to make a decision of whether to buy dollar deposits or euro deposits. If the dollar is depreciating today, so it's worth not very much compared to the euros, it's going to take a lot of dollars to buy that initial euro account. And if it's taken a lot of money to buy that initial euro account, then the rate of return you're going to get in that account is not going to be very high in the end. On the other hand, if there's appreciation of the domestic currency today, then this is going to raise the expected return of deposits in the foreign currency. So again, if the dollar is worth a lot compared to the euro, this means it doesn't take that many dollars to buy the euro account, and therefore it's going to increase the expected returns on that account in the future. Here's an example. I'd like you to take a moment to do these calculations on your own, and it should be able to show you that there's a negative relationship between the spot rate and the returns on foreign currency deposits. So go ahead and pause this recording so that you can solve the expected dollar return on the euro deposits in each of the different cases. And note that the interest rate on the euro deposit is going to stay at 5%. And we're also going to assume that the expected exchange rate in the future is $1.05 per euro, and that doesn't change. We will complicate this in future chapters, but for the moment, let's assume that the expected exchange rate doesn't change. Okay, so pause this recording and solve the expected dollar return on the euro deposits. And so here's the answers. I want you to notice on the left-hand column, the current exchange rate. We start with $1.07 per euro, and it goes down in small increments until we hit $1 per euro. This represents an appreciation of the dollar against the euro from top to bottom. So we should expect that there should be increasing returns in terms of the dollar return on the euro deposits, and that's what you calculated on the rightmost column. And so we see that with the current exchange rate at $1.07 per euro, this is going to give us a return of about 3.1%. But as we go down, once we hit an exchange rate of $1 per euro, then the expected rate of return is 10%. And if you graph these relationships between the current exchange rate and the expected dollar return on the euro deposits, we get a negative relationship, which we can see here. Okay, so this is how we graph the expected returns on the euro deposit in terms of dollars. And now we're going to add the returns for the dollar accounts as well. So again, we have a negative or downward sloping expected euro return line. The dollar return is going to be completely vertical, and there's a good reason for this. If you notice that the y-axis is the current spot rate, if you think about the spot rate and how would that affect the home currency directly, it's not. The dollar return rate is actually controlled by the central bank. We're going to be talking about that in depth in Chapter 15. Because it's not affected by the exchange rate, the dollar return curve is vertical. Now, the interest parity condition says that we have an equilibrium when the rate of return for the dollar accounts is equal to the expected euro rate of return in terms of dollars. So that happens at the intersection of these two curves. And what we get in the end then is an equilibrium exchange rate. And so if we put together the demand for dollar accounts and the demand for euro accounts, we find the equilibrium exchange rate in the market. So if you ever wondered how the exchange rates are determined, it is determined by the demands for foreign currency accounts. Now we want to know what's going to happen when we increase the returns to dollar accounts. So we're going to start with the picture that we had before. And what direction would the dollar return curve shift? Is it going to go to the left or the right if we have an increase in the dollar deposits? It should go to the right. When we have a shift of this curve to the right, then what's going to happen to the equilibrium exchange rate? We're going to find that the equilibrium exchange rate goes down. So remember that this is actually going to be an appreciation of the dollar. Now let's think of what's going to happen if we have an increase in the return to the euro deposits. So the European central banks get together and increase the interest rate for the euro. So again, we're going to start with the basic picture that we had before. In this case, what's going to happen to the curve for the expected euro return? Well, at every exchange rate or every spot rate, we're going to have an increase in the expected return of the euro deposits because the euro return was increased by the central banks. So we're going to have a shift again to the right. So how does this affect the spot rate between the dollar and the euro? It's going to increase it. And this is going to represent a depreciation of the dollar against the euro. So in summary, an increase in the interest rate paid on deposits denominated in a particular currency will increase the rate of return on those deposits. This leads to an appreciation of the currency. So, for a rise in the dollar interest rates, this is going to cause the dollar to appreciate. A rise in the euro interest rates is going to cause the dollar to depreciate in our example. The last concept that I want to cover in Chapter 14 is covered interest parity. So investors have a problem. They have the choice of investing either in domestic accounts or they can invest abroad. But when they're investing in foreign currency deposits, they also have to deal with the foreign exchange risk. So is there a solution to this problem? And as we talked about last Tuesday about the different types of exchange rates, what an investor can do is actually negotiate a forward rate so that they know exactly what they'll get out of the deposit a year hence. So for example, what is the rate of return on a foreign currency deposit using a forward rate? So first of all, what do we need to know? We need to know the home currency rate of return. And in this case, again, we're going to use the US dollar as the home currency. We need to know the foreign currency rate of return, which again, we're going to use the euro. We need to know the current spot rate, as well as the forward exchange rate in 1 year's time. So the rate of return in dollars terms is going to be almost exactly what we had before. So we have the rate of return on the dollar deposit plus, instead of using the expected spot rate a year from now, we're going to use the forward rate minus the current spot rate, and this quantity divided by the current spot rate. So again, this rate of return looks a lot like the rate of depreciation. It looks a lot like the expected rate of return, given the expected exchange rate in the future that we talked about before. So let's do an example. Suppose that you have $1 to invest in a dollar account or a euro deposit. Which do you choose? We're going to assume that the rate of return on the dollar accounts is 9%, and the rate of return on the euro accounts is 4%. The spot rate is $1.05 per euro. The forward rate is $1.113 per euro. So first of all, I'm going to define something called the forward premium. This is the forward rate minus the current spot rate, and this quantity is divided by this current spot rate. And you'll notice this looks an awful lot like the rate of depreciation that we looked at earlier. So the approximate rate of return in dollar terms is going to be what I had just mentioned before, the rate of return on the euro deposit plus this forward premium. So for our example, the rate of return on the euro deposit was 4%, so it's 0.04, plus the forward premium is 1.113 minus 1.05, and that quantity is divided by 1.05, and this equals 0.10. So the rate of return for the dollar account was given at 9%, or 0.09, and this is less than what we just found for the euro rate of return, which is going to be 0.10. And I just realized I have a typo here. It should be the rate of return, the expected rate of return on the euro deposit, including the forward premium. So in this case, everyone is going to buy euro deposits. So this brings us to the covered interest parity condition. And this is where the rate of return on the dollar deposits is equal to the covered rate of return on the euro deposit, which is the euro deposit plus the forward premium. If, as in the previous example, we have a case where the rate of return on the dollar deposit is less than the rate of return on the euro deposit plus the forward premium, then everyone's going to buy euro deposits, which will cause the euro to appreciate against the dollar. This will cause the current spot rate to increase until the covered parity condition will hold with equality. So again, this is sort of the same proof that we looked at earlier in the non-covered situation. So in the end, what is the forward rate? How do we calculate this? Well, note that we know the returns on dollar and euro accounts. So we know both of the R's, and we also know the current spot rate. This means that we can calculate the forward rate from the covered interest parity condition. So if you rearrange the covered interest parity condition, you'll get the expression below, and you can back out the forward rate. So when are the covered and non-covered interest parity conditions equal, and how are they different? The conditions are equal when the forward exchange rate is equal to the expected exchange rate, or the expected spot rate in a year's time. So intuitively, if two parties are negotiating a forward rate, what is the rate that they're likely to choose? They would choose the expected future spot rate. So if that's the case, if the forward rate equals the expected spot rate, what is the difference between the covered and non-covered transactions? The big difference is that the covered transactions are free from foreign exchange risk. So the forward rate is negotiated and will be paid out in that amount in a year's time, whereas the expected spot rate, there's no guarantee that will be the spot rate in the future. And in fact, the forward rate moves very, very closely with the expected spot rate. And that is the end of chapter 14.